Let's take a look at another problem. On this next one, starting on the first problem on the next page, a quality control analyst randomly selects 3 different car ignition systems from a manufacturing process that just produced 200 systems, including 5 that are defective. Assume that selections are done without replacement. Does the selection involve independent or dependent events? Okay. Well, first of all, let's talk about what we have. We've got a total of, 200 systems, 5 that are defective. So let's start out with that. So we've got 200 total, and of those 200, 5 are defective. And another piece of information they gave us is that we are making any selections without replacement. So the question is, does this involve independent events? Well, the first question should be is, whatever happens first, does it affect the next thing? Well, we are taking 5 defective out of 200. If I select a unit, whether or not it's defective or not defective, it doesn't matter because I am not replacing it, which means my numbers will change. At the very least, my total will now be 199. So I've changed something, which means that this is not independent. Something has changed. It was whatever happens next is dependent on what happened first. So does this involve independent events? No. And the reason why is it's because it's selections are made without replacement. So selections are made without replacement, and that is your huge problem. Okay, let's take a look at actually finding a probability for this. What is the probability in this first one that they're looking for, which is that all 3 are good, meaning that they are not defective. So the probability that all 3 ignition systems are not defective, they're good. That means I need the first thing to be not defective for the second one, and not defective for the third one. And again, the key word is that in between all these is I'm sticking the word and. I need all of these to be true. So what's your probability for your first person not being defective, or the first item not being defective? Well, there were 5 that were defective out of 200. That means the ones that are not defective are the other 195 are not defective. So the chances for the first one not being defective is the 195 that aren't out of the total of 200. Now the problem is, we said without replacement. So once I select that first not defective item, I am now, for my second item, down to only 194 out of 199. Now, I've had 2 that are selected. Now for my third one, I can't use either of the first 2. Now I'm down to 193 out of 198. And let's see, the ands are telling me, just like all the ones before this, that we are going to take all these probabilities and fractions and multiply them. So, multiplying straight across, we're going to multiply the 195, the 194, the 193, and we're going to be multiplying the 200, 199, and 198 across the bottom, and let's see what we end up with. So when we multiply straight across the top, we end up with our 7,301,190. And when we go straight across the bottom with the 200, 199, and 198, we end up with 7,880,400. And we'll divide those out to get our probability. So we'll take the 7,301,190 and divide that by the 7,880,400. And we will get a 0. Depending on how you round, or it's told around 0.93. And that's our final answer. Let's take a look at these next two events, these next two examples and their two events, and see whether or not these events would be independent or dependent. And this takes more of just like rational thought process and just thinking about what's going on. On this first one, finding that your calculator works is one event, finding that your computer works is another. Now, whether or not these are independent or dependent, which is what they're asking for, is based on whether or not one affects the other. If your calculator works, is that going to affect whether or not your computer works? No. If your computer works, is that going to affect whether or not your calculator works? No. So, what does that mean? They don't affect one another. It means they are independent. They're independent because they're not affecting one another. They're two completely separate things. Okay, here's another one. Part B looks at two different events. Randomly selecting a consumer who owns a computer, and the other event, randomly selecting a consumer who uses the internet. Now, these are more than likely dependent, because if you have a computer, you're more likely that you're going to need the internet. So that will affect whether or not you have a computer will affect whether or not you actually use the internet. So having a computer makes you more likely to use the internet. So they do affect one another. Whether or not you have a computer is going to affect whether or not you're using the internet, and vice versa. Okay, on this last one on this page, we've got the probability it will rain is 40% every day for the next 3 days. So that's our first thing that they're giving us. Our chances of rain for the next 3 days is 40% each day for the next 3 days. So let's see, there's two things they want us to find. On part A, they want to find the probability that it doesn't rain any of the 3 days. So no rain, all 3 is the first thing that they want us to find. Versus on the second one, they want us to find probability that it rains all 3 days. Okay. Well, we already know part of this is what's the probability of it raining, just period, is 40%. But we want to talk about all 3 days together. So it's 40% for each day. How do I generalize this to include all 3? Well, that's what we've been doing here. Well, you have to take into account each day separately. Well, the chances of it raining on the first day is the 40% or point. Remember, when we have percentages, we have to use them as decimals, so 0.40. But that's just for the first of the 3 days. We still have to look at the second and the third day. So they did say for the second day, it's still another 40%, so we can still use the 0.40. And for the third day, it's also 40%, so I can use another 0.40. But remember, just like this before, is I want all of these to happen. So they're and, so I need to be multiplying all these decimals. So I'm multiplying 0.40 times 0.40 times 0.40, or you can just write it as 0.40 raised to the third power, because they're all the same. So 0.40 times 0.40 times 0.40 is going to give us 0.064 as our probability of it raining all 3 days, which is really low. That's about 6%. Now let's look at the flip side. What are the chances of it raining none of the 3 days? This is not the opposite. This means for each day I want it to not rain. Well, what are the chances of it not raining each day? Well, if the chances of it raining each day is 40%, it means the chances of it not raining each day is 60%. That's for each day separately, though, just like before. So I need to do what we did before, which is take each day separately. So for the first day, our chances of it not raining is the 0.60 or 60%. But then also for the second day, it's another 0.60 or 60%. And for the third day, it's another 0.60 or 60%. But I need to take all three together, which means I'm going to need to multiply all three of these. So it's 0.60 times 0.60 times 0.60, or 0.60 to the third power is another way of doing it, which will give me a total of 0.216, which is about 21%, almost 22%. Let's take a look